to Let's Reboot Dev, the show where we take an existing tutorial or web app and we reboot it. Reboot is some might call it transactional microservices, others might call it a cloud programming framework, but in our opinion, it's basically just the most ergonomic way to create a distributed full stack application. So what we're going to do today is we're going to take a tutorial from just the straight up react.dev website. I believe this is the only tutorial that's actually on their website. But we're going to take this, formerly a front-end only library, and turn it into a full stack distributed durable application. We think this is the best way to see Reboot in action. So let's get started here. So what I'm going to do is I'm going to use a template that we have, and it is at GitHub, Reboot Node.js template. So this is there's not a whole lot of code in here, but this is a very simple way to get started with the Reboot app. So what we're going to do is we're going to click use this template, and we're going to create a new repository. I will be the owner of this repository. As you can see, I've done this once before, so we'll call it Reboot Tic-Tac-Toe, and then say a reboot version of React Tic-Tac-Toe. We'll make it public so that anyone who wants to can see it afterwards. Let's go ahead and create a repository. So while that is happening, oh, that happened faster than I thought it would. Okay, let's create a new code space on main. I really love to use code spaces. They're pretty great, but I actually prefer to use the desktop version as opposed to the online version, mostly because the way that they do port forwarding is a little bit cleaner in desktop. So we will open Visual Studio Code here. And now, while it's doing that, I will kind of talk through what we're actually going to do with this tic-tac-toe. So, this is all pretty straightforward, I think, but basically we've got a square component, which represents one of these squares. Then we have a board, which represents this playable surface right here. And then we have a game, which represents all of the board states for every individual move. Then we have some helper functions defined in line, and then it looks like at the bottom we also have a calculate winner, which just looks at the board state and figures out if there is a winner. So now that it has created our code space, we can take a quick look at what is in this this template. So it is a node. We're going to use a TypeScript backend. And so because of that, we actually have a package JSON here at the top level. This backend will be defined with TypeScript as well. So there's really not a whole lot in here. We just have two dependencies, one on Reboot and one on Reboot React. We actually don't need this one in here because we will be adding a package. Well, let's see, actually. I think we'll be using Vite, so it might be able to find this at the top level. Let's see. Okay, so what do we have here? We have this package JSON. We also have a script which calls rbtdev run. RBT is Reboot's CLI. And then the only other thing that we have at the top level that's worth talking about right now is this rbtrc. The RBT command line accepts a number of arguments and flags, but we also define this rbtrc just to make our lives easier so that we don't have to pass these flags every time we invoke RBT. We can just have it look at the rbtrc. So this is sort of separated into two segments. There's the proto commands, and then there's the dev run commands. So these are the commands and flags that will run when we run RBT proto C. That actually generates our code. And then RBT dev run is the thing that actually runs our code. So this flag, what it's telling us is that it's going to generate the Node.js specific code into a directory called API, and the React code we're also going to put into API. But if we wanted to, we could specify a different path here. But since Vite allows us to look outside of our source directory for code, we can just keep it all in one place, make our lives simpler. This gives our app a name. Having a name for your app allows you to save state between runs, which could be really handy for debugging and prototyping. It's also the name that we'll use when we want to delete all of the data in our database. And then the last thing is a command on where the application's entry point is. In this case, it's at backend source main. So that is sort of the outline of an rbtrc file. Let's take a look elsewhere. Well, actually, yeah, I think at this point we can get started. Well, there's really not a whole lot going on in here at the moment, so we can talk about this when we get to it. So I think the first thing that we will do is create our front end. So as I mentioned, we'll be using Vite. So I think we can just say npm create Vite at latest, if I remember my incantation correctly. Let's see if that works. So basically what we're saying here is we're creating a React TypeScript template. Vite allows for a generation of lots of different types of frameworks, but we're picking React and TypeScript this time. And yeah, so we should be good to go here. So I'm just basically going to drop all of this directly into here, but this is all just plain old JavaScript, and we actually want TypeScript. So beforehand, I just went ahead and updated all of the types, or some of the types, so that you wouldn't have to watch me do that in excruciating detail here. But yeah, this is basically what we have over here, just with a little extra required type information. Okay. So now what we can do is we can just say npm run dev. And you know what? I don't like which port it picks, so let's pick a different port. Okay, now let's see what we've got. Okay, we're almost there. Looks like we have some leftover styles, so let's pick the styles from here that we need. Looks like these are our styles, and we can just replace what we have in index.css with these new styles. Okay, let's see how we did. Cool. And X is the winner. Okay, great. So I think we're in a pretty good position now to start to reboot this. So we are going to lift up this state, which is called history here, but this is basically the state of the game. And then the only other piece of state here is current move, which is just an index. This state is an array of arrays. The inside array, so the array of arrays, that inside array, of which there are many, is the state of the board. And then the outer array, so all of those arrays, represents the entire game. Each one of these is a board state at a given move. So there are two pieces of state here. This is the whole state of the entire game, and then this is just the index at which kind of snapshot of the game we have. So I think at this point we're ready to create our API. Reboot uses protobuf to define our API schema. This works well because we are built on top of gRPC, and gRPC also uses protobuf. So basically what we need to do is just model our application in proto, and yeah, then we'll be off to the races. So let's create a new directory called API, and then let's give us a package file path. So I think inside of here we will create something called Tic-Tac-Toe. And then it's always a good idea to version your protos. So I'll give this a v1. Oops, I made a file. That's not what I want to do. Delete. Yes. And we'll actually create a folder called v1. And then inside of there, we will create something called game.proto. Okay, cool. So as is the case with all proto, we need a little bit of boilerplate up top. Syntax, we tell it proto 3 is the syntax that we're using. Our package is at Tic-Tac-Toe v1. And then we have to import RBT v1 alpha 1 options proto. So this is actually what is going to allow us to add the annotations to each one of our proto methods so that we can actually generate the code that we need to generate. I'll talk a little bit more about that in just a second. Okay, so the last thing that's a little uncommon if you've ever looked at proto before is we need to now create a message. That message will represent the state of our application. In this case, the entire state of our application. Obviously, if you're creating a more complex application, you'd have lots of different state types. But since this is proto, we represent that kind of piece of data as a message. So we're going to call this message game because it's going to represent the whole game. And then to tell it that it is the that it represents a piece of state in the reboot system, we will say that we will add the annotation RBT v1 alpha 1 and then state. And then since this is an array of arrays, the thing that we would probably do in production is to say that this is actually a repeated message of some other type. So we might say something like move here, and then each one of those had like a repeated string of, or maybe we would call this board. Each one of these would be a move, or maybe this. Anyway, basically to do an array of arrays, you would have a repeated message and then another repeated message. But I don't think I want to do that. I think I actually just want to make this really simple and call this a history and just make it a string. The reason for that is because we actually don't need to access the state on the backend. We're mostly just using this backend state as a way to serialize data between players when they move. So yeah, we'll just JSON stringify the array of arrays, and that is what will be saved on the backend. Okay, so now we're actually ready to define our methods. So we will do that with a service, and this thing will be called game methods. This naming convention is actually required. It shows that these are the methods that are associated with this piece of state. So when we define our methods, we'll actually pass in a state. These methods will get passed in this state. Okay. So now let's create an RPC. I think we're going to have two. We're going to have something that reads the entire history and then something that updates the entire history. Obviously, this is probably not what we would do in production, but this is an example. So we can do whatever we want. So let's just say this is history, and then history would take a history request. And that would return a history response. We need to give this one other option. So this is an RBT v1 alpha 1. And now we need to say what kind of a method this is. We do this because the reboot system needs to know how best to schedule and how to safely execute these different methods on the state type. For instance, reader methods can execute concurrently. So if we have a bunch of readers, that can scale out really easily. Writers, on the other hand, need to execute sequentially for the state to be updated correctly. Other things like a reader method cannot then call a writer method, because obviously the semantics of that would not be correct. So there are just things that, you know, this little state type, or this little option right here, gives our system a lot of information about what kind of method it is, and we can do a lot of things to improve the scalability, performance, and safety of your application by you telling us what kind of a method they are. Reader's one, writer's another. You can see the full list of methods that we support in our documentation. But another one, which we will not see in this example, but is really the heart of the Reboot system, is a transaction. So we'll get to that in another tutorial. Okay, so that's a reader. I think the only other thing we'll want to do is an update method. So update, of course, we'll take an update request, which returns an update response. And then here too, we take an RBT v1 alpha. Oh my gosh. This takes a writer method. Okay, cool. So the only thing left to do here is to define the rest of the messages. So message history request. This won't take anything. Message history response will return the same thing that we have up here, which is just the full serialized state. And then same thing down here, but the opposite. Update request will take and then update response. Okay, cool. So with that done, I think we basically have everything that we need to get started actually generating some code for us to use. So the first thing we're going to do, if we haven't already done this, is install Reboot and Reboot React. And then once we have installed Reboot and Reboot React, we can then generate the code that we will use for both the front end and back end based on this very minimal, simple API definition. And as you can see here, what we've chosen to do is generate that all into this API directory. So once we run rbtrc, that is where the output will be. And because we have installed RBT here with this Reboot package, we can run it via a script, or once this is installed, we could also do npx rbt proto. But we need to wait for that to finish installing for that to happen. So let's create just a little script for us here to make our lives easier, so that we can just run npm run dev rpc. Okay, so the installation was complete, and now we can run npm run proto. And let's see if that sticks our proto in the API directory. Great. So this is the TypeScript backend code. This is the TypeScript React code. And then these are the types that are shared between the React and backend code, Node.js code. Okay. Cool. So I think we are now ready to actually create our servicers. So this, well, and you know what, actually, npm run dev backend. Let's actually run our app. So the cool thing about everything that happens in the initialize is, well, one, this will rerun the app anytime that anything in here changes and is saved. But everything in initialize, which basically just runs anytime your app updates and starts the state, creates the kind of initial state for your application, everything in here must run idempotently. So even though our app is going to be restarting over and over again, it's only going to write that state durably once, which is very handy. And then we're going to create some servicers here, which will actually service the application. And we pass those to this array right here. So I think we have everything that we need to get started. So I think the first thing that we're going to do is create some servicers. And now we need to import some of the generated code. So we're going to import game from API Tic-Tac-Toe RBT. And then game servicer extends game servicer. Servicer. Okay, great. And now we're going to pass this to servicers. And it's complaining that the methods required on game servicer do not exist. So let's create them. We have two. One is a history. The first thing that it gets is a context. Remember, this was a reader method. So we can give it a reader context. It takes a state, which will be the game state. That we defined here. And then it also takes a request. So we're going to get in here a history request, a history response, an update request, and an update response. So this will be the history request. We also want something here, it'll just make our lives a little nicer. Something called partial message from buff build protobuf. So this allows us to return a promise of a partial message, of a update, a history response. And this is nice because then we can just return this instead of returning a new history response. Just a little bit nicer, I think. Okay, and the only thing that we're returning here is the history. So state.history is all that we need here. And we don't actually need this request. And I don't think we need this context either. I don't know why this is... History does exist on GameState. I'm quite sure of it. I'll need to look into why it doesn't think it does there. Okay, and now same thing for update. Async update. Update takes a context of a writer context, a state also of game state, and then a request. And why did I spell it like that? Of a update request. And then similarly, this is going to return not a history response, but a update response. And then this will just kind of be the opposite. We return nothing, but we update state.history to be equal to request.history. And similarly, context is not used here. Okay, cool. So somewhere where context is used is here, where we're going to construct a game. Anytime you construct a state, you give it an ID. We're just going to call this one something simple. Okay, and now as I mentioned, we need to do this idempotently. And then we're going to call our method. So the first thing to any method invocation is the context. And then is what we actually want to pass. So in this case, we're going to do history. And we are going to use the same strategy that they've used over here for default state, except remember that we modeled this as a string, so we need to JSON stringify this. Okay. Async. What don't you? Oh, of course not. We need to await, not async it. Okay. What do you think about that? You know what? This is a new code space, so let's do npx prettier. Much nicer. And we have a working backend. Look at that. Okay, this opened up in a different browser. Let's see what we got here. Cool. So this is our game state. We've got one item with the key tic-tac-toe, and it has this history of a null string of strings. I'm sorry, array of arrays, represented as a string. Okay, so now we're basically ready to start replacing this local state with a real shared backend state. So I'm going to import some custom hooks to help me do that. The first one is going to be called useGame. useGame is a custom hook that gives us access to that game and its methods. So we also know that we want to use a custom hook for our reader. Anytime we have a reader method, we can access it reactively with one of these use custom hooks. So we know that we want that here. So let's get it here. And then every reactive reader custom hook has a response object on it. This took no arguments, so we can just call it like that. And then let's see what we get on response. So this should all still compile. Let's see here. Aha, of course. We need a reboot context. So let's actually open this up. And we're going to import two things, a reboot client. And just be aware that this API is going away. We're not going to have you construct the reboot client. In the future, you're just going to need the reboot client provider. But for now, this is not using the version of the code that removes that. So we're going to use the old school client. Okay, cool. And what reboot client expects is a handle to the backend. Pretty simple. So we'll just pass it http:// localhost 9991. Okay, and then we need the reboot client provider, which takes a client equal to client. Great. Yes, this needs to be a new reboot client. Okay, wonderful. So now we're in a position where we're actually receiving undefined for this at first, and then we're receiving the history. And we're receiving it twice because this is in strict mode, and strict mode is great. We actually have something similar to strict mode in our code, but it's just so that we see the output only once. Let's turn off strict mode for now. Okay, cool. So now I think we can actually go about replacing some of this local state. So I think what I want to say is, let's replace this history with the history that we're actually getting from the server. So what I want to say is const history. If we have a response, use the history that's on it. If not, I think I want to, oh, and actually, you know what we need to do? We need to JSON parse that history. And then if not, we'll just kind of use, I think, the same sensible default that we have here of this array of nulls. Okay, cool. So this should actually continue to work. And yeah, I think that that actually does work. Great. Okay. So now what we need to do is we need to look at where we're calling this set history. And we call that in handle play. And I don't think we actually want to do that anymore. I think we want to set history based on how long our history array is. So let's create a use effect. And we're going to have the dependency array have response in it. And then anytime we get a response back, we're going to set the current move to be history.length -1. So I think we can actually remove both of these now, both that setter and this getter. And now when we, yeah, okay, I think that continued to work. I don't see any errors here or here. So then the last thing that we need to do is when we actually call handle play here on the board, which is the thing that calculates the next history based on my next squares and current move, I think there is where we want to call update. So update is a method that we can get from useGame, just like history. And what we can do is we can call update, and update will just take a history, and that history will be a JSON stringify of next history. Okay. So I think if I, yes. Okay, that all appears to be working. And if I open up another tab, we have a winner. Nice. And look, this is fully durable now. If I want to, I can expunge the state here. So we can see that was our game state before. Now I can say, let's do rbtdev expunge, name equals app. Sorry, npx, rbtdev expunge, name app. Yes, I do. And then let's run our backend again so we can start from scratch. Cool. We're back online now, so we shouldn't see any more errors in the console. And yeah, let's see if we can make a winner here. O is really bad at playing checkers. Cool. So now the only thing that we have left to do is to wire up this go to move. Obviously this is not changing the state over here because this is still local state. So I will leave that as an exercise to the reader to add this to the remote state so that you can really share this game between two people. So yeah, that was it. That should give you some understanding of how easy it is to take an existing app and reboot it. At this point, we now have an app that is completely scalable, is totally possible that you could play it online with a friend. And yeah, that's it. Thanks so much for watching.